How has been your day? Sure, you are doing great. And we are back again to trigonometry. And if you are following our videos, you will recall when we started with the proving of the formulas. And then at this point in time, we are going further to discuss about the Pythagoras theorem and the angles involved. So now, just follow us. Don't forget to click on that subscription button and share with your friends that are having challenges with mathematics. And place your comments as we update you in our subsequent video. Thank you very much. Once again, recall that we have a triangle, a right angle triangle, whose alphabets are A, B, C, and the sides are, if this is capital letter B in a triangle, the side facing it will be small letter b. Then if this is capital letter A, the side facing it will be small letter A. Then if this is C, the side facing it will be small letter C. And you need to understand that in a triangle, this is a right angle triangle because it's having a 90 degree. And you need to understand that the longest side of this triangle now is B. If you trace very well, the longest side is B. And the longest side in a triangle is referred to as the hypotenuse. So our hypotenuse is equal to B. And now let's assume the angle is situated here. We are putting an angle here, and if an angle is here, this side is facing this angle. So the side facing this angle, the side facing the angle is referred to as the opposite. So let the opposite be equal to C. The third side of the triangle is referred to as the adjacent. The adjacent side is equal to A. Now, we want to prove the Pythagoras theorem with respect to these alphabets and the sides. Pythagoras theorem states that in a right angle triangle, the square on the hypotenuse is equal to the sum of the square of the other two sides. In a right angle triangle, this is a right angle triangle, what's the hypotenuse B? The square of the hypotenuse is equal to the sum of the square of the other two sides, that is A square plus C square. The other two sides are the opposite and the adjacent. So this is Pythagoras theorem. Pythagoras theorem. Those of you who don't understand Pythagoras theorem, you don't need to carry big definition in your head. What you just have to understand is the square, the longest side of the hypotenuse, which is B, is equal to the sum of the square of the other two sides. This is just Pythagoras theorem. Now the next thing we'll do is we want to prove some of the angles relating to these sides. Recall that sin theta is equal to opposite over hypotenuse, which is equal to what? What is the opposite? Let's assume this is the theta. The opposite is what? C. What is the hypotenuse B? Which is what? C over B. Now, tan theta, cos theta. Let's assume this is the theta. What is cos? Adjacent over hypotenuse. If you remember from our previous video, our cos theta is adjacent over hypotenuse, which is car. Where is the adjacent A? Where is the hypotenuse B? It's equal to A over B. Now the last one is tan theta. Tan theta, remember from our previous video, our tan theta, which is TOA, using the SOHCAHTOA, is opposite over adjacent. Opposite over adjacent, what is the opposite side of this triangle now? Is C. What is the adjacent side? Is A. So we have C over A. Now, we want to prove further sin theta over cos theta. In our previous video, we said it's equal to tan theta. Let's prove it. Sin theta is equal to cos theta is equal to, will give us tan theta. What is sin theta? Sin theta is C over B. Proof. Let's prove it now. Sin theta over cos theta now. What's sin theta? Sin theta is what? C over B. C over B. And what's cos theta? Cos theta is A over B all over A over B. It's equal to C over B. Remember that by the time we take this to this other side, the sign division changes to multiplication. It becomes the reverse, the inverse. The denominator becomes the numerator and the numerator becomes the denominator. So we are going to have B over A. So B will cancel B, then we have C over A. So what is tan theta? Recall that tan theta is what? C over A, which is equal to what? Tan theta, as proof. Now, what if the inverse is the case now? Cos theta over sin theta. So what will cos theta over sin theta give to us? Cos theta over sin theta will give us cot theta, which is the inverse of sin theta. Now, what is cos theta? Cos theta is A over B. So therefore, cos theta, which is A over B, all over sin theta, which is what? C over B, is equal to A over B. Remember, we are changing to times now. This one will go up, this one will come down. C over B. Sorry, B over C, yes. B over C. This one will cancel this. Yeah, and then we are having A over C. Now you'll be wondering what is cot theta. Cot theta is equal to 1 over tan theta. So what is 1 over tan theta? I remember 1 over tan is 1 over tan theta, which is what? Tan theta, which is C over A, will give us, the inverse now will give us A over C. So now cot theta is equal to A over C, and we have proved that cot theta over sin theta is equal to cot theta, which is A over C, cot theta. So these are some of the things you need to understand about this trigonometry. And let's move further. And now we are to address the issue of the Pythagoras theorem with respect to the sin theta and cos theta now. Now, what if we have sin squared theta plus cos squared theta? Now, sin squared theta plus cos squared theta, prove that is equal to 1. How do we go about this? Please, I want you to, sorry for my this mathematics, so just follow me as I continue with the provings. Now, sin theta is what? Sin theta is C over B. Then we have C over B, then all squared, plus what is cos theta? Cos theta is equal to A over B plus A over B all squared. So therefore, we are going to have C squared over B squared, C squared over B squared plus A squared over B squared. Yes. Now, at the end of the day, what is the LCM? The LCM is what? B squared. B squared. So we are going to have B squared and B squared, 1 times C squared plus B squared that B squared 1 times A squared. Now let's come back to our Pythagoras theorem. Pythagoras theorem is equal to what? Pythagoras theorem, as proved earlier on, stated that B squared is equal to A squared plus C squared. So if Pythagoras theorem says that B squared is equal to A squared is equal to A squared plus C squared. So now we are having C squared plus A squared. C squared plus A squared now. So what do we do? Whenever we see C squared plus A squared, let us put B squared. So let us substitute A squared plus C squared for B squared. Therefore, we are going to have C squared plus A squared all over B squared. So now let's replace this with B squared. It's equal to b squared over p squared. So b squared divided by b squared, we have 1. So therefore we can say sine squared theta plus cos squared theta is equal to 1. Proved. Yeah, that is it. So that is that's about Pythagoras theorem. You just understand the SOHCAHTOA very well, understand the Pythagoras theorem, and you'll be able to explore various formulas in Pythagoras theorem. Thank you as you watch this video. I really wish you best of luck to those doing exams, and share with your friends to those having challenges with these Pythagoras and SOHCAHTOA. Thank you. Don't forget to subscribe, click on the like, and share with your friends. Love you and have a nice day. Bye.